If points K, I, T, and E form the kite K, I, T, E, and the diagonals of the kite intersect at M, determine A, the gradient of KT, B, the gradient of IE, C, the value of K, and D, the coordinates of E. Here we're working with a kite. So let's start with a quick sketch. Let's put in our X and Y axis. Point K has the coordinates 2, 11. So you can plot K up here and label its coordinates. Point I has the coordinates K, 6. We don't yet know the value of K. So all we know is that it has a Y coordinate of 6. So let's draw a horizontal line in red over here on the axis where Y is 6. Point I will sit somewhere on this line. Let's leave this for now and we can move on to point T with coordinates -6, -5. We can draw this point down here and label it T along with the coordinates. We don't have either coordinate of point E, so at this stage we don't know where it will go. We know that the kite has two diagonals. K is the first letter in the name and T is the third. So KT is a diagonal and we can draw it in over here. A kite's diagonals are always perpendicular. So let's draw another diagonal perpendicular to the one we've just drawn. And we can make it touch the red horizontal line over here. We don't yet know if KITE is named in a clockwise direction or an anti-clockwise direction. So let's say that this is point I, which means that point E should be up here. Now we can join our points and draw our kite. But this is already a mess and we haven't even included the midpoint N yet. Remember that we use a diagram to give us a better idea of what we're working with. It does not need to be to scale, but it does need to show the general shape of the quadrilateral. The Cartesian plane can help you figure out where your points lie, but in cases like this, you can draw a diagram without the axes. So let's clean this up. The question tells us we are working with a kite. So let's draw a simple sketch. We know that a kite has two pairs of adjacent sides that are equal. So we can draw two sides up here and another two down here. Now we have a kite. Let's say that this top vertex is K and we can fill in the coordinates. From the name kite, we know that K and T is a diagonal. Let's draw in point T and we can label the coordinates. Now we need to consider points I and E. We don't know if kite is labeled in a clockwise or anti-clockwise direction. So for now, let's assume that it's clockwise, which means I will be on the right side of the kite. Because we aren't sure that this is in fact point I, let's plot our point in red and we can label it I along with coordinates K6. Now we have K, I, and T. So the final point on the left must be E. Again, we aren't sure that this is in fact point E. So let's plot this point in red and write down the unknown coordinates PQ. We know that point K and T are in the correct places, but even though we aren't exactly sure of points I and E, they are still vertices on the kite. KT is one diagonal, which means IE must be the other. We can draw this diagonal in as well. Furthermore, the question also tells us that the diagonals intersect at M. So let's plot this point and label it M. Now we have a better diagram to work with. So let's start with part A. Determine the gradients of KT. We can use the gradient formula to find the gradient of KT. Let's say that K is our first point and T is our second. So we can say the gradient m of kt is equal to negative 5 minus 11 all over negative 6 minus 2. Negative 5 minus 11 gives us negative 16 over negative 6 minus 2, which is negative 8. Here the negatives will cancel, and 16 divided by 8 gives us positive 2. And now we can move on to part B. Determine the gradient of IE. From our work with kites in Euclidean geometry, we have learned that the diagonals of a kite are perpendicular and that the longer diagonal bisects the shorter one. The diagonals are perpendicular, so let's draw a 90-degree angle between the diagonals on our diagram over here. This means that the diagonal IE is perpendicular to the diagonal KT, and we have just found the gradient of KT is 2. So the gradient of IE must be the negative reciprocal value. So let's change 2 into a fraction, 2 over 1. Now we can say the gradient of IE is equal to 2 is positive, which means that this is negative. Now we can flip our fraction and we get 1 over 2. And now we can move on to part C. Determine the value of k. We don't have the coordinates of point E, so we can't use the midpoint M, but we've just found the gradient of IE to be negative 1 over 2. Now points E, M, and I all lie on the same straight line, which means that they are collinear. This means they have the same gradient. So if the gradient of line IE is negative 1 over 2, then the gradient of MI is also negative 1 over 2. We can make a note of this over here. Now we can use the gradient formula to find the unknown coordinate of k. Let's say that I is our first point and M is our second. So we can say the gradient, which we know is negative 1 over 2, is equal to 6 minus 5 over k plus 1. Now we need to solve for k. So let's multiply by the lowest common denominators. We're going to multiply negative 1 by k plus 1. On the right, 6 minus 5 gives us 1. We're going to multiply it by this denominator of 2. On the left, we now have negative 1 multiplied by k, which is negative k. Negative 1 multiplied by positive 1 gives us negative 1, is equal to, on the right, we just have 2. But we want to solve for k, so we need to make k positive. So we move it to the right-hand side of the equal sign. On the left, we have this negative 1. Then we can move 2, we say minus 2. And finally, negative 1 minus 2 gives us negative 3. And this is equal to k.